Hi everyone. Today we're going to continue on from what we were doing in class yesterday where we were talking about the rational root theorem. I'm going to do this example problem. It's got a little bit of everything in it, so it hopefully will kind of help with what we were doing yesterday. It says to identify all of the real roots of that polynomial equation. That's up on the screen. When it refers to real roots, that doesn't necessarily just mean integers. It means it could also be fractions, and it could be roots that have radicals in them. So we're going to go through this problem, and you'll see all of the different types of roots that you can have because they're all combined into this one problem. The first thing we have to do is apply the rational root theorem. And remember that said to figure out all of the possible roots, so all of my possible roots, I need to take all of the factors of my constant term and divide them by all of the factors of my leading coefficient. So all of the factors of 6 would be plus or minus 1, plus or minus 2, excuse me, plus or minus 3, and plus or minus 6. And then I have to divide that by all of the possible factors of my leading coefficient. So that would be plus or minus 1, plus or minus 2, plus or minus 4. Now, if I were to sort of figure out what all of those possible things are, I need to take all of the possible factors in my numerator and divide them by all of the possible factors in my denominator. So anything divided by 1 is itself, so I know for sure that I might have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. But now I have to go on to the second denominator here, which is 2. So now I have to take every term in the numerator and divide it by 2. So I could also have plus or minus 1/2, because I would have 1 over 2. Then I could have plus or minus 2 over 2, which is just 1, and I already have that here, so there's no need for me to write that again. I'm going to move on to 3. I could have plus or minus 3 over 2, right? That's a possibility. Or I could have plus or minus 6 over 2, which would give me 3, and I already have that, so I don't need to write it again. Now we'll go to our denominator of 4. I'm just going to write it down here because I'm running out of room over there. So I could have plus or minus 1/4. I could have plus or minus 2/4, which reduces to 1/2. I already have that, so I don't need to write it again. I could have plus or minus 3/4. And then I could have plus or minus 6/4, but that reduces to 3/2, which I already have. So this is a list of all of my possible roots. That doesn't mean they all are roots. These are just all of the possibilities. Okay? And so now, there's a lot of possibilities there, right? I don't want to go through testing them all. What if I went through each and every one of these and I didn't get to one that worked until I got all the way down here? That's a lot of synthetic division you'd have to do to get there. So let me show you a quick way to kind of help you out, excuse me, to get an idea of what your roots are going to be. If you go to your graphing calculator, okay, go to your graphing calculator, and go ahead and put that equation into y equals, which I did that already. And then I hit graph. Or you can hit zoom 6. That always brings you to a standard window. And you'll see this is my graph. And if I'm just looking at it like that, that doesn't really help me much because everything is so squished in, it's hard to see. So if it wasn't squished all together, you could probably find what you need. But the way this one is, it's kind of hard to see. So what I want to do is I want to zoom in. Okay, so if I hit zoom, and then I hit option 2, I'm going to zoom in, and I'm just going to hit enter. And it'll zoom in a little bit for me, and I can get a little bit better idea of what's going on here. And if you look, you can see right here, somewhere right around, looks like this would be -1 right here, but this is about -3/4 or so. So that looks like that could be a root. This might be 1/2, I'm not really sure. This looks like it goes right through 2, so the 2 could be a root. Okay, so I'm going to use that knowledge to kind of help me sort of narrow down which numbers I want to try. So I'm going to try 2 because I think that's an easy one to start with. Okay, so I'm going to try 2. I'm going to do synthetic division. So I have the 2 here and then all of my coefficients. 4, -21, 18, 19, and -6. I'm going to go ahead and do my synthetic division. Bring the 4 down, multiply 2 and 4, that gives me 8. If I add -21 and 8, that gives me -13. 2 times -13 is -26. When I add those together, I get -8. 2 times -8 is -16. When I add those together, I get 3. 2 times 3 is 2 times 3 is 6. And when I add those together, -6 and 6, that gives me 0. I got my remainder of 0, so I know that 2 is a root. Now, since 2 is a root, these are the coefficients of my new polynomial. Sometimes they call it a depressed polynomial. Not that it's sad, it's just because it's a modified version of the original one. Okay, so if 2 is my root, that means x minus 2 is my factor. We talked about that yesterday. And then here I would have 4x. Let me fix that there. These are my coefficients, so I would have 4x to the third because my initial power was to the fourth. So now I have to decrease that by 1. So 4x to the third minus 13x squared minus 8x plus 3. So now I'm going to take this new polynomial and I'm going to go ahead and figure out what I want to use here. Okay, I'm going to do synthetic division again because the way this is right now, there's nothing I can really do with it. I can't factor it because I do have 4 terms, but the product of the outside terms doesn't equal the product of the inside terms. So I'm going to have to do synthetic division once again. I'm going to go back to my possible roots. So look at this polynomial. Remember, your possible roots are all of your constant term, factors of your constant term divided by the factors of your leading coefficients. So I have plus or minus 1, plus or minus 3 for the factors of 3 over plus or minus 1, plus or minus 2, plus or minus 4. Right, so those are all of my possible ones. Remember when we were looking at the calculator, we said it kind of looks like there's a root at -3/4. So I'm going to go ahead and try that right off the bat. I could sit here and try 3. I could sit here and try 1. But look at the graph. I'm nowhere near crossing the x-axis at 1, so x can't equal 1. So I'm not even going to waste my time trying it. Go to something that makes sense. 3/4 is a pretty good guess, or excuse me, -3/4 is a pretty good guess. So I'm going to do that. And I know that that kind of scares people because it's a fraction. Okay, but it doesn't change the way that you do it. So let's go ahead and do this. So I have -3/4. I'm using these coefficients. I have 4, -13, -8, and 3. So those are my coefficients. Okay, let's do this. So I'm going to bring my 4 down. Then I'm going to multiply -3/4 times 4. You could do that in your calculator. That just gives you -3. Okay. When you add those together, you get -16. Now I'm doing -3/4 times -16. That gives me +12. When I combine those together, I end up with 4. -3/4 times 4 gives me -3. When I add those together, I get 0. Perfect. Okay, so now I also know that -3/4 is a root. And now I have this new polynomial. Because this was the cubic, my new polynomial starts with x squared. So I have 4x squared minus 16x plus 4 is equal to 0. I'm just going to go on to a new screen here. So let's figure out what we had. We had x equals 2 as one of our roots. We had x equals -3/4 as one of our roots. And now we have this other polynomial, which is 4x squared minus 16x plus 4 is equal to 0. Remember, I should end up with 4 solutions because this is a 4th degree polynomial. Now I'm down to something that I know how to factor if I can factor it. Okay, this I know I can take out a GCF. If I take out a GCF of 4, I end up with x squared minus 4x plus 1 equals 0. And when I look at this, there's nothing I can factor, right? There are no two numbers that add to -4 and multiply to 1, which means I either need to complete the square or I need to use the quadratic formula. I'm going to go ahead and use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac, all of that over 2a. So that would give me minus -4 plus or minus the square root of -4 squared minus 4 times 1 times 1 all over 2 times 1, and that would give me 4 plus or minus, right, because a negative times a negative makes that positive. This would be 16 minus 4 over 2. I'm going to go back over here, and that gives me 4 plus or minus the square root of 12 over 2. Not done yet, folks. I have to simplify. I can simplify the square root of 12. Factors of 12 are 4 and 3. Okay, here's my perfect square. So I end up with 4 plus or minus 2 square root of 3 over 2. I'm still not done because I can simplify this. You always want to give your solutions in simplest form. So I can divide both of my numerators by that denominator. 4 divided by 2 is 2. 2 divided by 2 is 1. So 1 square root of 3, that's the same as just square root of 3. So my 4 roots, then I have these 2, and then I have the conjugate pair. Remember that word conjugate. 2 plus or minus the square root of 3, and those are my other 2 roots. And those are my 4 solutions to that polynomial equation. Okay, if it's a 4th degree equation, you should have 4 roots. That is what they are. Leave that in the form it is. Notice I have 2 rational solutions and I have 2 irrational solutions, but they are all real solutions. So you could have 4 rational, or you could have 2 rational, 2 irrational. Remember, if you have 1 irrational, you're going to have 2. Okay, they always come in conjugate pairs, so you're never going to have an odd number of irrational solutions. That's it for this. Your assignment tonight is a worksheet. It's posted on the course page. Have a great weekend. I'll see you all next week. Take care, everybody. Bye-bye.